catalysts for growth, discovery, innovation, and economic growth in America. I'm grateful for the opportunity to work with Ranking Member Babin and all of the members as we consider the important issues before the subcommittee. We began by focusing our first hearing on human space exploration, and we have a lot to do, and today we are turning our attention to science. Space science has come a long way in the 60 years since NASA's founding and James Van Allen's launch of Explorer-1, America's first science satellite, in 1958. While Explorer-1 provided initial glimpses into what could be discovered from vantage points above and beyond the surface of Earth, NASA's science spacecraft have gone on to study our sun and every planet in the solar system, to look back into the early universe, and to enhance our understanding of our own planet. Today, NASA's Science Mission Directorate represents a $6.9 billion investment that funds space-based and suborbital science missions, ground-based research, data analysis, and technology development. These elements support NASA's programs focused on planetary science, earth science, and applications, astrophysics and heliophysics, the study of the sun and its interactions with the Earth and the solar system. Through these programs, scientists are seeking answers to questions, to fundamental questions. What is dark energy, and how and why is the universe expanding, and at what rate? How have the many chemical and physical processes that shaped the solar system evolved and interacted over time? What are the structure, function, and biodiversity of Earth's ecosystems, and how and why are they changing in time and space? What are the origins of the sun's activity, and how can we predict variations in space environment? In pursuing answers to these and other questions, NASA's scientific findings increasingly become interwoven into our everyday lives. From decisions to reroute aircraft due to solar activity and space weather, to surveying the skies for potentially harmful near-Earth asteroids, to using ocean color and temperature maps for commercial fishery forecasting, or in using satellite data to assess the impacts of our changing climate, and much more. Through an organized science community-led process known as decadal surveys, NASA's Science Mission Directorate has benefited from a systemic approach to setting priorities that guide NASA's planetary heliophysics, astrophysics, and earth science program over 10 years. Not only do the decadal surveys guide the content of NASA science programs, they also help us commit to the highest priorities identified by the science community. The decadal surveys keep us honest and focused on top priorities when funding constraints or competing interests arise. However, consistently following and implementing decadal priorities has not always been easy. The complexity involved in ambitious, large-scale missions has led, in some cases, to significant cost and schedule growth. So we must be vigilant in ensuring NASA is as innovative in program and cost management as it is in advancing scientific discovery. How can NASA and the community both encourage ambitious breakthrough science while minimizing unanticipated costs and delays that may come with pushing the edges of innovation? And must pushing the edges of innovation and discovery always be equated to large and expensive missions? Or can the use of small satellites and CubeSats and hosted payloads, where appropriate, also help us acquire scientific observations and measurements at a lower cost? It is clear we have a lot to discuss, and I look forward to our witnesses' testimony and perspectives on these critical issues. The chair now recognizes Ranking Member Babin for an opening statement.
Thank you, Madam Chair. Appreciate it, and appreciate all of you expert witnesses for your testimony. Year after year, NASA amazes the world with new wonders to behold, and the Science Mission Directorate at NASA makes that happen. The Hubble Space Telescope has informed our understanding of the age of the universe, its rate of expansion, and provided a breathtaking perspective of our place in the cosmos with its deep field image. Other observatories like the Compton Gamma Ray Observatory and the Chandra X-ray Observatory and the Spitzer Space Telescope returned stunning images of our universe's astronomical phenomena like supernova and neutron stars. The Curiosity rover observed whirlwinds called dust devils on Mars and continues to search for the building blocks of life on the red planet. We've sent probes to every planet in our solar system, traveled through the rings of Saturn, and landed on its surface with the Cassini-Huygens mission, explored Jupiter and its fascinating moons with the Galileo and Juno missions, and most recently visited Pluto with the New Horizons probe and revealed its heart-shaped icy surface. We've located, tracked, characterized, and visited asteroids and comets with missions like Stardust, Deep Impact, WISE, and Dawn. NASA missions like Kepler and the TESS discovered thousands of planets around other stars, some of which may be habitable zones that could harbor life. We've sent spacecraft like the Parker Solar Probe to interrogate the Sun. And beyond the solar system into interstellar space with the Voyager spacecraft, NASA developed the next generation of weather satellites for NOAA that decreases the warning time for severe weather events like hurricanes and tornadoes and provides reliable forecasts for farmers and fishermen, pilots, and every American. These are stunning achievements. However, NASA has more to offer. NASA continues to develop the James Webb Space Telescope, the flagship follow-on to the Hubble Space Telescope that stands to fundamentally rewrite the textbooks. The Europa Clipper mission will explore Jupiter's icy ocean world that has intrigued scientists because of its potential to harbor life. Lucy and Psyche will explore unique asteroids, and OSIRIS-REx will even return a sample to Earth. The Mars 2020 rover will also prepare and store samples for a future sample return mission. We live in a very exciting time. As NASA continues to awe us with scientific discoveries, we should be ever mindful that the Science Mission Directorate is also responsible for critical national missions that go beyond science. Congress charged NASA to find 90% of 140-meter asteroids that could harm the Earth by 2020. NASA carries out this vital task through SMD's Planetary Defense Coordination Office. NASA also operates a fleet of heliophysics spacecraft that informs our understanding of space weather, that impacts everything from the electrical grid to communications and GPS signals. Similarly, NASA's Joint Agency Satellite Division manages the development of our nation's critical weather satellites that serve as the very backbone of weather forecasting. The administration's budget request for science is very strong. And while it is a reduction from the fiscal year 19 appropriation, it represents the highest budget request in history. The request was developed before the final appropriation for FY19 was even determined. If you compare this request to the final budget request of the Obama administration, which many on this committee supported, this request is much stronger. This request represents an increase of $1.1 billion, or 21% over President Obama's last budget request for discretionary spending in FY17. That same FY17 budget request from the previous administration projected a notional FY20 request of $5.627 billion. President Trump's proposed science budget is $6.39 billion. That is $767 million, or 13.6% more than President Obama planned for FY20. This is a solid request for science at NASA, but that doesn't mean that we should let our guard down. Cost overruns like those experienced by JWST, the Mars 2020 rover, and the ISAT-2 come at the expense of other missions like WFIRST and PACE, and threaten the health of not just the Science Mission Directorate, but also the entire agency. And that's why strong leadership is required to instill discipline and program management early and often. Tough choices have to be made to ensure that overruns do not threaten existing and future missions. The nation's space science enterprise cannot afford to have another JWST or ISAT-2. I yield back.
Thank you, Mr. Babin. The chair now recognizes the chairwoman of the full committee, Ms. Johnson, for an opening statement.
Thank you very much, and good morning, Madam Chair, for holding this hearing on discovery on the frontiers of space, exploring NASA's science mission. Scientific research has been part of NASA's mission since the agency's founding. The National Aeronautics and Space Act of 1958, in the expansion of human knowledge, a phenomenon in the atmosphere and space. And one of the 8 objectives of the nation's aeronautical and space activities. Since the 1958 Act, NASA and the nation has invested in the systematic scientific exploration of our planet, bodies in the solar system, the sun, and the universe that have answered many questions and generated many more. That scientific exploration has come with surprises. For example, who would have imagined that Pluto may have active volcano-spewing ice, or that there is a mysterious force causing our universe to expand at an accelerating rate? NASA has been at the forefront of discoveries such as these in space and Earth science since its inception, with a cadence of small, medium, and large missions, and supporting research and technology that keep the public engaged, inspired, and learning. That's why it perplexes me as to why the administration would even consider raiding science to pay for a moon program. Yet, that may be where NASA is headed, despite the administrators' assurances to the contrary. The one-year budget amendment that came over in May would give the administrator carte blanche authority to move funds among NASA's accounts from this year forward. If he determines that the transfers are necessary in support of establishment of a U.S. strategic presence on the moon, why? Because the administration, it seems, may not request in the coming years what NASA actually needs for its crash program to get astronauts to the moon by 2024. According to media articles, NASA officials are stating that hard choices lie ahead and that NASA find money for the moon program from within the agency's other programs. This isn't a new tactic. The George W. Bush administration, which initiated the last moon program, tried the same approach. According to a 2006 National Academies report, the Bush administration indicated its intention to cut significantly from science to pay for its moon program. The scars from those cuts are still felt today, especially in the life and physical sciences research program, which experienced reductions that decimated the pipeline of microgravity research and drove scientists to other fields. The talented women and men at NASA and its partner institutions deserve better. Those who have become acquainted with the NASA workforce know that they will work tirelessly in an effort to meet a goal. Passion can take us so far, but it alone can't build the rockets and the landers, the spacesuits and the habitats, and all of the other elements needed for a safe and sustainable Moon-Mars program. NASA needs a solid plan, sufficient resources, people, infrastructure over multiple years to enable deep space human exploration. Starving science to fund human exploration is not the answer. I know our witnesses will have much to say about the opportunities and challenges facing NASA's space and Earth sciences, and I look forward to your testimony. I thank you and yield back.
Thank you, Madam Chairwoman. If there are any other members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I would like to introduce our witnesses today. Our first witness is Dr. Thomas Zurbuchen. Since October, Dr. Zurbuchen has served as the Associate Administrator for NASA's Science Mission Directorate. Previously, Dr. Zurbuchen was a professor of space and aerospace engineering at the University of Michigan in Ann Arbor. He was also the university's founding director of the Center for Entrepreneurship in the College of Engineering. Dr. Zurbuchen's experience includes research in solar and heliospheric physics, that's a mouthful, experimental space research, space systems, and innovation and entrepreneurship. During his career, Dr. Zurbuchen has been involved with several NASA science missions: Ulysses, the messenger spacecraft to Mercury, and the Advanced Composition Explorer. He has also been part of 2 National Academy standing committees, as well as various science and technology definition teams for new NASA missions. Dr. Zurbuchen earned his Master of Science and PhD in Physics from the University of Bern in Switzerland. Our next witness is Dr. Chelle Gentemann. Dr. Gentemann is a senior scientist at Earth and Space Research, a nonprofit research institute in Seattle, Washington, and an affiliate of the University of Washington. Previously, Dr. Gentemann served as a visiting scholar to the NASA Jet Propulsion Laboratory and senior principal scientist at Remote Sensing Systems. Dr. Gentemann is currently the co-chair of the Standing Committee on Earth Science and Applications from Space and is on the Academy's Intelligence, Science, and Technology Experts Group. Her most recent research focuses on using cloud computing, open source software development, machine learning, and algorithm development using remote sensing data, air-sea interactions, and upper ocean physical processes. Dr. Gentemann received her bachelor's degree in science from the Massachusetts Institute of Technology, a Master of Science in Physical Oceanography from the Scripps Institution of Oceanography, and a doctorate in meteorology and physical oceanography from the University of Miami. Welcome. Our third witness is Dr. David Spergel. Dr. Spergel is the Charles Young Professor of Astronomy at Princeton University. He is the founding director of the Center for Computational Astrophysics at the Flatiron Institute. Dr. Spergel is the former chair of the Space Studies Board and is currently the co-chair of the Wide Field Infrared Survey Telescope, WFIRST, science team. Dr. Spergel's work has focused on using laboratory experiments and astronomical observations to probe the nature of dark matter and look for new physics. Dr. Spergel earned his bachelor's degree from Princeton University and his doctorate in astronomy from Harvard University. Our fourth and final witness is Dr. Mark Sykes. Dr. Sykes is the Chief Executive Officer and Director of the Planetary Science Institute. He has served as the chair of the Division for Planetary Sciences of the American Astronomical Society. He is also a co-investigator on the NASA Dawn mission project to the asteroid Vesta and the Dwarf Planet Ceres. He received his bachelor's in physics from the University of Oregon, where he studied the first known black hole system, Cygnus X1. He received a Master of Electronic Science from Oregon Graduate Center and a PhD in Planetary Sciences from the University of Arizona. Welcome to all of you. As our witnesses, you should know that you will each have 5 minutes for your spoken testimony, and your full written testimony will be included in the record for the hearing. When you have completed your spoken testimony, we will begin with questions from each member, and each member will have 5 minutes to question the panel. We will start today with Dr. Zurbuchen. Dr. Zurbuchen.
Thanks so much. Chair Horn, Ranking Member Babin, and members of the subcommittee, I'm pleased to testify today. I want to thank you for your commitment to NASA and to NASA science. We'll discuss how this FY20 budget request enables us to succeed in 3 strategic focus areas: advancing national exploration goals, maintaining a balanced science program, and delivering true impact through our investments. Regarding advancing national exploration goals, Artemis is NASA's lunar exploration program that will send humans to the moon by 2024. develop a sustainable human presence there in 2028, and set the stage for human exploration of Mars, the ultimate goal of NASA's human exploration program. Robotic missions delivered by commercial landers will be the first Artemis elements to land on the moon. Through NASA's Science's CLIPS initiative, we are incentivizing speed and drawing on commercial and international partners to enable science investigations and technology demonstrations on the moon ahead of human return. We recently selected 3 commercial moon landing service providers for the earliest missions in 2020-21. These missions will acquire new science measurements and enable important technology demonstrations to provide data that will inform future exploration systems needed for astronauts. The amended budget request also includes $90 million for the purchase of a commercial services to deliver a rover to the moon. SMD is committed to executing a balanced and integrating science program that is informed by the decadal surveys of the national academies. In planetary science, NASA's robust Mars program is providing groundbreaking science and exploration information. This request supports continued progress of the Mars 2020 rover, which will search for the evidence of life on the red planet and collect a cache of samples. With this request, NASA will start development of a Mars sample return mission, completing the first round trip to another planet. In parallel, the cutting-edge Europa Clipper, a strategic mission to fly to Jupiter's moon, will be our first step in exploring ocean worlds and their potential habitability for extraterrestrial life. Competitively selected missions like OSIRIS-REx and the Mars Lander InSight are critical ingredients to our program, as are the Psyche and Lucy missions to explore distant asteroids. In astrophysics, the budget supports the revised launch date of James Webb, the largest and most powerful space telescope to date. Webb will examine the first galaxies that formed in the atmospheres of nearby planets outside its solar system. After a successful planet-hunting mission Kepler, we are now focused on TESS, which will provide a rich catalog of worlds around nearby stars, including valuable targets for Webb to explore in the future. In August 2018, our heliophysics program launched a Parker Solar Probe. Parker has already completed 2 of its 24 near-solar passes, flying to within 15 million miles of our star, the Sun. We recently selected the IMAP mission that will image the outer boundary of the sphere of influence of our Sun. In 2018, NASA launched 2 strategic missions recommended by the Earth Science Decadal. GRACE Follow-On is measuring the mass of ice sheets and glaciers and tracking Earth's water movements across the planet, while ICESat-2 is providing unprecedented data on the topography of ice, topography, of course, it's an interesting word, of ice, forests, and oceans. EcoStress and JADI are now on the ISS, measuring agricultural water use and drought conditions, as well as creating 3D maps of the world's forests. The request funds continued progress on Landsat 9 for a launch in 21, together with our U.S. Geological Survey partners. NASA's Earth Science continues using innovative partnerships and new approaches, including the acquisition of commercial data products from small satellite constellations. Our work has societal value to the U.S. and beyond. Our Earth Science program teams with partners to develop and demonstrate applications in areas like disaster management, public health, and resource management that provide direct benefit to our nation. Heliophysics-funded research enables the predictions necessary to safeguard life and society on Earth and the outward journey of humans and robotic explorers. And in addition, NASA looks for near-Earth objects to assess if they pose any threat to us. We found 96% of the potentially hazardous NEOs that over 1 kilometer in diameter, and a third of those at 140 or more. The request funds the technology to deflect such bodies using the DART mission. With this request, SMD will help pave the way for the success of Artemis program, initiate the first round-trip mission to the red planet with a Mars sample return mission, and continue investing in the groundbreaking work our scientists, engineers, and technologists do every day to answer humanity's most fundamental question and to inspire learners of all ages. Thank you for the opportunity to testify here today.
Thank you, Dr. Zurbuchen. Dr. Gentemann.
Thank you. Chairwoman Horn, Ranking Minority Member, and members of the committee, I want to thank you for the opportunity to testify today. As Chairwoman Horn said, I am co-chair of the National Academy Standing Committee on Earth Science and Applications from Space, CSAS. However, the opinions that I express today should be attributed to me unless stated otherwise. CSAS produced the most recent 10-year roadmap or decadal survey to guide U.S. investments in Earth system science for societal benefit. It's charged with monitoring the progress in the implementation of the decadal survey's recommendations. The decadal survey discusses in detail the benefits to the nation from a robust Earth science program at NASA, NOAA, and USGS. Drawing on their own expertise and hundreds of solicited concept proposals and white papers from the community, about 100 of the nation's leading Earth scientists, space system engineers, and policy experts worked for almost 2 years to develop a consensus on Earth science priorities. The survey made recommendations for the programs of all of its sponsors, but I will focus on those directed at NASA today. Most importantly, these are to complete the series of existing or previously planned observations from the 2007 survey called the Program of Record, to implement the designated essential observations, which are cost-capped medium and large-size observing systems, to implement Earth System Explorer high-priority observations, which are cost-capped medium-size observing systems, to create a new program element called Incubator to advanced future capabilities, and to continue the cost-capped Earth Venture line from the 2007 decadal, along with the addition of a new element called Continuity, designed to facilitate development of low-cost means to sustain critical observations. The survey report presents a plan for an integrated program. Completing the program of record is important because the decadal survey recommendations assume and build on this baseline from the 2007 decadal survey. The program of record includes both PACE and Clario Pathfinder. Elimination of these missions in the program of record undermines the entire decadal survey planning and prioritization process. PACE supports multiple research thrusts and is a key element in the survey's planned constellation of satellites that will give scientists and policymakers a clear understanding of how to use Earth system science for societal benefit. Clario Pathfinder will provide the ability to intercalibrate instruments in space at accuracies 5 to 10 times beyond current capabilities. Implementation of the full recommended program will require appropriations beyond that assumed by the Decadal Survey Committee. In particular, additional funds would be needed to complete the full suite of designated essential and Earth System Explorer high-priority observations as planned. These are foundational observations selected to ensure that the survey's highest priority science and application questions can be effectively addressed. Finally, I note that the decadal survey process began in 2015. Rapid advancements in using commercial cloud computing and open source software for science have outpaced planned activities. The survey didn't plan for the additional resources needed for a wholesale move of NASA data assets onto the cloud, support for the open source software libraries that underpin the rapid scientific advancements and possible applications, or how to enable interdisciplinary science and commercial applications that will likely subsequently flourish. In my view, this is one example of where comparatively small new investments have the potential to deliver outsized benefits. NASA's vast data resources and robust research community make it well poised to be a global leader in this effort. Jumpstarting these activities in NASA could grow the public-private cloud partnership and energize the research community. As you consider NASA's reauthorization, I hope that the committee sees the value of the decadal survey process and provides the funding to implement the decadal survey, including the program of record, and both designated and Earth Explorer observables as recommended. Thank you for your time.
Thank you, Dr. Gentemann. Dr. Spergel.
I want to thank Chairwoman Horn and the committee for this opportunity to speak. I'm David Spergel, a Princeton professor, director of the Center for Computational Astrophysics, and a past chair of the Space Studies Board. While these experiences inform my testimony, these views are my own. Many of NASA's most important activities, from Mars exploration to studying extrasolar planets to understanding the cosmos, are centuries-long projects. The modern version of the construction of the great medieval cathedrals. The decadal surveys provide blueprints for constructing these cathedrals, and NASA science has thrived by being guided by these plans. Monitoring our rapidly changing planet is both a great scientific challenge and a pressing societal need. Thriving on a changing planet, a decadal strategy for Earth observation from space identifies the highest priority study areas, the most important observables, and recommends structuring new NASA missions accordingly. I want to reinforce Dr. Gentemann's comments and urge the committee to charge NASA to implement these priorities. Addressing climate change begins with deepening our understanding of Earth. The search for life is another grand challenge. Within our own solar system, we have learned that water is everywhere. Comets bring water to Moon and to Mercury. Mars not only has a wet past, but still has liquid water today. Outer planet moons such as Europa host vast oceans beneath their icy shells, a discovery that suggests new potential habitable destinations. Did any of these systems once host life? Do they host life today? To answer these questions, NASA is in the midst of a set of interlocking missions exploring the red planet. As outlined in the Planetary Decadal Survey, the Mars 2020 mission is the next step in this program, culminating with the return of carefully selected samples from Mars. NASA is also making progress in building the Europa Clipper. The Planetary Decadal Survey, however, did not identify a major investment in studying the lifeless Moon as one of its highest priorities. I'm concerned that high-priority SMD programs will be terminated to enable lower priority science and accelerating the lunar program. Understanding the dominant component of our universe, dark energy, is another grand challenge. Both Europe and China are leading missions to studying it. Fortunately, enabled by congressional support, NASA continues to move forward with WFIRST, the Astronomy Decadal's top priority mission. As co-chair of its science team, I'm happy to say that WFIRST is meeting its technical requirements and is on track for a 2025 launch and on budget. Now, all of these missions are enabled by technology developed both internally within NASA and by external advances. Regrettably, the Space Technology Mission Directorate is reducing these long-term investments for its future science missions and is focusing its resources towards the short-term goal of Moon 2024. This is eating the seed corn of future projects. New commercial advances are offering NASA new opportunities for innovation. The desire to build self-driving cars advances autonomous systems. The machine learning revolution provides novel tools, both for analyzing Facebook images and NASA images. GPUs are now pushing high-performance computing hardware. Open code development is driving innovation across industry and academia. NASA and the science community needs to be open to these new innovation sources. While NASA does face immediate challenges like successfully completing and launching JWST, this is an incredibly exciting time for science. NASA satellites have discovered thousands of exoplanets and detected the brilliant flash from the merger of two neutron stars. NASA's launched a satellite that will literally touch the sun. NASA's exploration of our solar system is revealing new insights into our origins. Its satellite observations are deepening our understanding of the rapidly changing Earth. Most importantly, each of these discoveries raises new questions that drive science forward. These discoveries were enabled by an agency guided by the community science priorities through the decadal surveys, and I urge you to continue to let these surveys guide our science programs. Thank you.
Thank you, Dr. Spergel. Dr. Sykes.
Chairwoman Horn, Ranking Member Babin, members of the committee, and Chairwoman Johnson, thank you for the opportunity to appear before you today. As a former chair of the NASA Small Bodies Assessment Group, I would like to begin by congratulating Dr. Zurbuchen on Administrator Bridenstine's recent announcement that NASA will be proceeding with the Near-Earth Object Camera, NEOCAM mission. This space-based infrared survey of near-Earth asteroids and beyond has been a high priority for science, planetary defense, space resource utilization, and targets for human exploration for almost a decade. This mission would not exist but for the vision, leadership, and sheer management skills of the NEOCAM PI, Dr. Amy Meinzer. Leveraging her experience as PI of the NEOWISE mission, Dr. Meinzer has spent 15 years building a team and a mission that promises remarkable discoveries, the retirement of the congressional mandate to find those objects that threaten our planet, and the necessary groundwork for expanding the future of our species in space. Dr. Meinzer is a role model not just for young women who aspire to have careers in science, but for young men as well. I'd like now to address the administration's initiative to return to the moon by 2020. In the President's proposed fiscal 2020 budget amendments to NASA, the administration asks for the authority, quote, to transfer funds between appropriations accounts in the event that the administrator determines that the transfers are necessary in support of establishment of a U.S. strategic presence on the moon. The language authorizes transfers in this fiscal year and in subsequent fiscal years, including funds appropriated in prior acts. This is a disturbing request. It appears to allow for the complete reorganization of the agency, including expunging space science if desired, without any congressional oversight. This must be rejected. On a more positive note, science provides essential support to human exploration. Scientists are the pathfinders, literally. They define where we can go and what we can strive to do there. They determine the operational environment, the resources, and the hazards. We should establish a dedicated science support team for human lunar operations. This should consist of lunar experts as well as heliophysicists. Their purpose is not to do independent research, but to marshal our rich data and knowledge of the moon and its environment to support human operations, to anticipate their needs, to participate in planning, and to identify what new information is needed and how best and most cost-effectively to obtain it in a timely fashion. I support the President's request to fund a lunar rover, at least one. It should be deployed in advance of our return to the moon, particularly if there is desire to establish a long-term operational presence. The choice of a location at the South Pole is in part to access craters having permanently shadowed regions containing evidence for water ice. A rover is needed to assay any water ice and to inform what kind of resource recovery and processing would be required. In the meantime, we also need to study and mitigate the impact of human operations on the lunar environment, particularly its exospheric atmosphere. Finally, every day, discoveries are being made not just by operating spacecraft, but by work funded by NASA research and data analysis programs. These programs lay the foundation and justification for future missions. They provide a continuing return on investment in these missions by generating new knowledge, even decades after the data was taken. These are core programs, and I am concerned that they are not being supported at the levels recommended by the Planetary Decadal Survey. I'm further concerned about the extent to which resources from these programs are being funneled to NASA Center scientists without competition, according to public statements, at times inconsistent, by NASA officials. The details of this program, including its costs and impact on resources for competed research programs, need to be investigated and made public. I believe that the American taxpayers deserve the most bang for the buck from their federally funded research programs. The core of that is competition. Scientists compete for grants and contracts all the time. It is not for the faint of heart. But competition is further undermined when NASA, I believe, alone among federal agencies, hides cost information from proposal review panels and directs them not to take cost into consideration in their assessment of proposed research. This started before Dr. Zurbuchen's arrival. We need to look at the buck and not just the bang. And the subject matter experts on review panels are in the best position to provide that assessment to selecting officials. The United States has defined the forefront of solar system exploration for more than half a century, but we cannot take it for granted. Thank you.
Thank you, Dr. Sykes, and thank you to all of our witnesses. We will now begin the first round of questions, and the chair recognizes herself for 5 minutes. Dr. Spergel, Gentemann, and Sykes, the subcommittee will be working to reauthorize NASA in the coming months. What are your top 3 priorities for NASA reauthorization and why?
I'll start. As I said in my statement, it's to complete the program of record, to fund the designated observables, essential observations, and the Earth System Explorer high priority observations. Following the decadal survey, and why, is because following the decadal survey recommendations is based on a huge community effort to maximize the societal benefit from Earth science observations. And this is the program that has been recommended to do so. Thank you.
Thank you. Dr. Spergel?
My first priority would be to implement the priorities of the decadal surveys in earth science, heliophysics, planetary science, and astrophysics. Another priority would be to assure that the SDMD continues to make investments in science and developing technology for science.
Thank you. Dr. Sykes?
Similarly, I think that we need to pay attention to the decadal recommendations of having a balanced portfolio. Too much is often attention is placed to the most expensive flagship missions, which have the most cost volatility, and then we tend to lose the discovery missions, the New Frontier, the competed missions, which are cost capped. So there's a recommended cadence for these smaller missions. I think that needs to have more attention paid to it, and likewise, the smallest programs, the research and data analysis programs, need to be adequately, perhaps better than adequately, funded, because this is the foundation of our U.S. solar system exploration program.
Thank you. Dr. Zurbuchen, Administrator Bridenstine has stated publicly that he doesn't intend to redirect funds from other programs, such as science, to pay for the Moon Initiative. However, as noted by Chairwoman Johnson, the administration's budget amendment that was sent to Congress would, and I quote, and Dr. Sykes expressed concern about this as well, authorize the National Aeronautics and Space Administrator to transfer funds between appropriations accounts in the event that the administrator determines the transfers are necessary in support of establishment of a U.S. strategic presence on the Moon. In addition to a recent article in Ars Technica that quotes a NASA official stating, "I don't think we're going to be able to get the entire budget as new money. We're going to have to look for some efficiencies and make some cuts internal to the agency, and that's where it's going to be hard." Dr. Zurbuchen, are you currently planning or engaged in planning for scenarios for current or future cuts, delays, or deferrals or reductions in scope to Science Mission Directorate programs or missions for FY 2021 and beyond to fund the Moon Mars 2024 program?
Our budget process for FY21 has just started, and I have not been director or am I engaged in any scenario planning with a massive downside of to the science program.
Okay, thank you. If so, if you were to have to look at those cuts, what would the potential for those cuts mean for the science programs and the balance within the science programs?
The way I have implemented every cut or every also upper relative to a budget that I had before is that I and our team and the administrator has been very supportive in public as well as in our own meetings. We use the decadals to accommodate both uppers and cuts relative to that. That will mean, for example, that we actually protect the RNA programs with the highest priority, for example, in planetary as in heliophysics. That it would mean that we protect PI class missions kind of over others and so forth. That, of course, always comes with an asterisk. For example, when you have a launch window of a mission next year, it is unreasonable through the eyes of a taxpayer to take money out of that mission, because it's much better to launch it instead of spending $500 million after the fact because of the fact that you moved some money out, $50 million or something. So it's with that caveat that we're using the decadal guidance.
Thank you, Dr. Zurbuchen. I have more, but I'll save for the next round. I see my time is up. Ranking member.
Thank you, Madam Chair. Dr. Zurbuchen, NASA recently awarded contracts to 3 companies as part of the commercial lunar payload services that will deliver landers to the moon's surface. A condition of the procurement stipulates that awardees must be U.S. companies. One of the companies that won a contract features a design team from India that competed in the Google Lunar X Prize. A recent article by Quartz was titled, "America's First Private Moon Lander Will Be Engineered in India." While this partnership appears to comply with NASA's solicitation, the optics obviously are not good. Can you assure the U.S. taxpayer that we aren't simply outsourcing space exploration when we have companies designing lunar landers right here in America?
Thank you for that question. Of course, you recognize that there's 3 selections we made, including 2 that where such questions did not come up. The one that you're talking about, this particular company, has to undergo, before we spend any dollars on it, has to undergo a full review of the very question that you're asking. We already told them, we actually reviewed it at the beginning, and we want to use the very same rules that we're using for launch vehicles as well, that basically stipulate that the majority of all of the manufacturing and design of this particular lander has to be done in the U.S. We're going to go through one more review, an in-depth review, to ensure that very fact.
Okay, thank you. And Dr. Sykes, we often hear that NASA should have a balanced science portfolio. However, other agencies like NOAA fund Earth science activities. The NSF funds astronomy, and NOAA and the Department of Defense fund heliophysics. How important is NASA funding to the planetary science community, and are there other significant sources of funding for planetary science other than NASA?
Mr. Ranking Member, that's a very important question. The planetary science community kind of stands out from these other communities because planetary science in the modern age is the creation of NASA. Astronomy was around for hundreds of years and is deeply embedded in universities. Heliophysics, there's communication concerns about space weather, there's industry and large industries associated with the important areas of Earth science. Planetary really has NASA as its sole customer, and so NASA funding for our space exploration enterprise is basically the only market in town. And so the stability of that funding is critical for maintaining our ability to engage in that activity into the future.
Okay. And then Dr. Zurbuchen, one more time. I represent Johnson Space Center, home of the Astromaterials Acquisition and Curation Office that documents, preserves, and prepares samples from the Moon, asteroids, comets, solar wind, and Mars. And is this office prepared to receive new lunar samples from future missions, or would additional resources be necessary to fully study these very important artifacts?
We're currently actually kicking off an analysis of that very question. See, there's samples that will come back with 2 characteristics we have not had before. The first type of sample, especially from the southern areas of the moon, or the polar areas of the moon, I should say, because the north also has them,
right,
are cold samples. So cryo type of samples that we want to bring back and hold there. Those are samples that the likes of which we have not had before. The second type of sample that we're thinking about is coming back from areas where we want to analyze biology potential, or at least the transition of chemistry to biology. In both cases, we believe there's additional investments required, and we want to work with the center to that. I already informed the center director that will occur.
Okay. And lastly, Dr. Sykes again, NASA plans on leveraging public-private partnerships to explore the moon. They've also stated that they will take a more commercial approach. What customer other than NASA do you see on the horizon that would make this commercial?
Well, everything's commercial at the end, Congressman. I think that this is a new path for developing new vendors for the government. I mean, we've had the innovations by SpaceX and other companies that have developed rockets outside of the normal process and given us some great products that we could purchase. But at the moment, the only customer that I see, and I can be wrong, for what's being done right now under the quote commercial thing is with the government as the primary customer.
Okay, thank you, and I yield back.
Thank you, Ranking Member Babin. The chair recognizes Chairwoman Johnson for 5 minutes.
Thank you very much. Dr. Spergel, in your written statement, you noted the impressive work of other nations in pursuing missions to study dark energy, one of the highest priority questions about the nature of the universe. Could you elaborate on your comment, and do you have any concerns regarding the state of the U.S. astrophysics or science in general as compared to other nations?
Well, there are two important missions. One is the European Space Agency's Euclid mission. Now, this falls in the category of something we've done a lot of, which is working together with the Europeans. We're a partner in the Euclid mission and are providing key components, and American scientists will participate in the Euclid work. And we've been designing the WFIRST mission to be complementary to the Euclid mission, to carry out a science program that goes beyond Euclid and also complements it. Perhaps of more concern is the Chinese space program. The Chinese are building a 2-meter optical telescope that will fly on their space station and are flying a large camera with that. Like us with WFIRST, they are taking advantage of technologies developed by their defense industries. And in one hand, I think it's very good to see that the Chinese starting to play a role in fundamental science. On the other hand, I think it's concerning that we might end up yielding leadership in an area where, dark energy is something that was discovered by American scientists, and a lot of important work is being done here, to China. And I see the Chinese universities trying to attract really outstanding people from the United States. I see them making big investments, and I think it's important that we maintain our leadership in science and technology. And I think that's why, one of the reasons why it's important that we continue to invest and push forward with projects like the WFIRST mission.
Thank you. Any other comments from other panelists?
Congresswoman, I think that one thing we also need to keep in mind is that, China's coming up, and they're becoming involved in all areas of space exploration. Their Chang'e missions have been very impressive, and what they're planning for the future, will also be. But we need to be a leader not because of we want to stay ahead of the other guy, and let the other guy define the directions that we go in just to keep ahead. But we do it because it's good for ourselves. It's good for our economy. It's good for our society to continue to invest in these broad range across earth science and astrophysics and heliophysics and planetary science to understand the world that we live in and to because as we pull back from that, as evidenced by like trying to cut back on science team support for missions and things like that, to kind of nickel and diming things down. Not that I'm advocating just throwing money at things, but to really be making solid investments in these areas, that we will fall behind and other nations will push ahead, and they're not doing it to just get ahead of us. They're doing it for their own purposes, and we should be likewise deciding what our purposes are and pursuing them vigorously.
Thank you. Yes.
I'd also like to add that in earth science, there's a similar situation, which is the Chinese have a very robust Earth observing satellite program, which is in contrast to our program where we're considering reducing the program of record and not following the decadal survey guidelines to do the essential and high priority observations. China is launching Earth observing satellite after Earth observing satellite and working with Europe to establish leadership. And I hope that the U.S. continues their investment in earth science so that we can remain a global leader in this area and it's for our societal benefit.
Thank you.
Congresswoman, could I make one more comment? I don't see China as a threat. I see them as a potential partner in a lot of these areas, a partner for advancing what we want to do. And so I think it's a mistake to look at them as a boogeyman.
Thank you. Yes.
think the discussion that we're having here is a complicated discussion, and because both aspects are relevant. So first of all, we are the leaders, and you should not have somebody else in my job if the person, if you would expect something else than me to say, I worry about remaining the leader and I want to be ahead, actually moving forward faster than the ones who come behind us. At the same time, I do believe one of the most important elements of science is the ability of nations to come together and work on problems that transcend boundaries or even political boundaries that separate them from each other. Over a long time, it's those kind of activities that have brought us together as humans and have made us better overall. And I do hope as we go forward and learn about these other countries, whatever it might be, whether it's China, whether it's Russia, whether it's other countries, that we get better at this, because we sure want them to work on public science using the policy that we have pioneered, where all data are out there for the entire science community to use worldwide.
Thank you very much. My time has expired.
Thank you, Chairwoman. The chair now recognizes Mr. Brooks for 5 minutes.
Dr. Zurbuchen, these questions and comments will be primarily for you. I'm looking at your written testimony to this subcommittee, and it states, quote, "We are building for the long term, and this time we're going to the moon to stay," end quote. Later on it says NASA, quote, "looks to land humans on the moon within 5 years," end quote. After describing the Artemis 1 and Artemis 2 missions, you go on to say, quote, "Then the Artemis 3 mission will send the first crew to the lunar surface using commercial human landing services that depart from the Gateway outpost orbiting the moon," end quote. So at a minimum, we've got Artemis 1, Artemis 2, Artemis 3, the Gateway outpost that has to be designed, built, launched into lunar orbit. What's the total additional amount of money NASA needs in order to accomplish this landing on the moon with humans by 2024?
That's a question that we're grappling with as we go forward and do the analysis. We already submitted for FY20 the incremental, request at $1.6 billion for that year. The increments for 21 and beyond will be part of the next budget proposal as we go forward. It's a question that we're currently working with, and of course, my part of that is the science part, which are the science parts which are well defined, and I can talk about in much more detail.
Well, I'm on an authorization committee. Obviously, this is Space Subcommittee related. And for us in Congress to be able to grapple with these things, we need some idea of how much a cost is expected to be incurred over the next 5 years. Are you telling me that, yeah, we've got the $1.6 billion more or less for FY 2020, but we have no idea whatsoever what the next 4 years cost will be in order to accomplish this human landing by 2024?
We're in the process of working through that right now.
I understand you're in the process, but do you have any idea as to what the cost ranges may be, minimal to high, so far in this process, or do we literally have no idea what we're getting into when we talk about Artemis 1, Artemis 2, Artemis 3, and Gateway?
I'm not, at this moment in time, able to talk about all the elements of that, and especially in the Directorate where most of the funding is incurred, which is not the Science Mission Directorate that I'm working.
Let me ask the same question, but with respect to 2028, by which time we're supposed to have a sustainable moon surface operation. Do you have any idea as to how much additional money NASA is going to need in order for us to have a permanent human presence on the south pole of the moon by 2028? Any idea?
The budget proposal that you have in front of you in 2020.
I'm talking not just that 1 year. I get the 1 year, but it's more than 1 year, and we've got a budget and plan. Do you have any range of numbers that you can share with us and the American people about what we're getting into when we try to put this outpost on the moon?
At this moment in time, I don't have a range of numbers that I can share.
All right, let's talk about the Gateway outpost for a moment. Can you please describe what that is in a way that helps American taxpayers understand what they're paying for in terms of size or weight or rooms or how it might compare to the International Space Station, something that gives American taxpayers a reference point as to what this gateway that's going to be circling the moon on a permanent basis looks like.
The gateway also is, of course, funded out of the human directorate, not out of our directorate, but is the way I think of it is like an outpost we have as a high altitude camp next to a mountain. I'm from the mountains. You know, you go out there, it's a small, very simple.
Okay, what does
place for
small
living.
mean? Tell me when you say small, is that a one-room vehicle that's orbiting the moon?
Perhaps
or-
it's a two-room vehicle, or you know, small relative to the size of number of people involved. It is simple at this moment in time to enable the early goal of 24.
I understand the purpose of it. Let me go to my last question. With reference to the gateway, you talk about solar electric propulsion. What is that?
Solar electric propulsion is a way of accelerating objects, spacecraft around. We use it in science. In this case, it will be used for a gateway. It basically loads up. We bring a gas with us, such as a noble gas, or that cesium or something else that basically sits there, and we use an electric voltage that we get from the power of which we get from the sun to accelerate those particles out the back and therefore propel us forward.
Well, thank you, Dr. Zurbuchen, for your answering my questions as best you're able. For what it's worth, no other representative of NASA has been able to tell us what this cost might be either.
Thanks.
Thank you, Madam Chairman.
Thank you, Mr. Brooks. The chair now recognizes Mr. Barra for 5 minutes.
Thank you, Madam Chairwoman. So I understand Mr. Brooks's line of questioning is, if we're thinking about multi-year and potentially multi-decadal missions, to have some sense of what that sequence looks like. And when I think about it in the context of the Apollo mission, I think there was a sense of goal that didn't span one administration, but went from one administration to the next and gave some certainty to NASA what that ultimate goal was. I've heard each of you talk about the importance of the decadal survey, of kind of an objective process that is scientific, not politically based, and then really kind of rank orders it. And each of you has emphasized the importance of, once this survey is out there, to really try to, as best as possible, adhere to the recommendations in the survey. Because again, when you're talking about science and you're talking about doing things that you may not have done before, there has to be a longer-term commitment. Maybe Dr. Gentemann, if you want to just describe, briefly what the decadal survey process looks like and why it is so important.
Thank you. The decadal survey process starts with the academies issuing one or two, maybe RFIs, requests for informations from the community, to one or both of those white papers. Often, you have a specific word limit. Those white papers are generated, I think, for the Earth Science Decadal, there were 290. Some of these were written by one or two authors. Others were written by hundreds. So you end up having the opinion, a consensus opinion of multiple communities within the earth science. Those white papers are then given to subcommittees who distill them down. For the earth science, they were distilled to, I believe, 130 science questions that were seen as important by the community. Those 130 science questions were distilled to 35 observables. Those were then prioritized and ranked so that there could be, if one observable maybe addressed multiple scientific questions, you would prioritize that higher. This was a very difficult and thoughtful process, which is why the community stands behind it so strongly. Thank you.
And Dr. Sykes, what's the downside of not trying to adhere to the decadal survey recommendations?
Well, then it's just kind of random in terms of what happens, and our development becomes more constrained by political considerations than science considerations. So it's a way of coming together. The value of the decadal is it's supposed to represent a consensus of the community. It's a process that could be improved. I know the Academy has its limits if it was up to me and I was involved in the first planetary decadal survey, I would allow public comment on the committee reports and the steering committee report before things are finalized.
So it's not a perfect process, but it is a
But it
very
is-
good process.
Yeah, it's a good process. We started to solicit white papers from the community back 20 years ago. The astronomers were very jealous of that because they would like to have the individual input, and getting that community input is, I think, essential.
And it's something that, that we as members of Congress with oversight should pay attention to and help guide us in our authorizing process as well as kind of the appropriations process.
If I can make one comment, Congressman, but often we're too distracted by the bright, shiny objects. The largest project recommended by the decadals, those are, on the planetary side at least, it's the recommendation for the largest mission. It's not the top recommendation of the survey, and we need to pay attention to the little stuff too.
Right. So in the decadal survey, are they ranking order of what programs and objectives we should? They don't always rank order the big shiny objects first, though.
Oh,
They
yeah.
rank order.
Yeah, in planetary they do. What are the recommendations for the largest missions? What kind of medium missions should be pursued?
So this is where, when we're authorizing and we're thinking about the budget, we should sit down with the NASA administrators, scientists, et cetera, and make some of those trade-offs, taking small programs as well as large programs into account. Yeah, I'm about out of time, so I will actually yield back.
Thank you, Mr. Barra. The chair recognizes Mr. Olson for 5 minutes.
I thank the chair and a big Texas welcome to our 4 expert witnesses. I want to talk about going back to the moon. I had the honor to spend a whole day with the most recent American to walk on the moon, Captain Gene Cernan. He's back home in Texas 22 for a better part of a day, just drive around and talk to kids about getting excited about NASA and space. Our discussions were overshadowed by the Obama administration's cancellation of the Constellation project, the one that's supposed to take us back to the moon under George W. Bush. That was sort of shading the whole environment down there. But Captain Cernan was very adamant about going to the moon. He said that's the best place to go to prepare for going to Mars. He's pointed out that we've only spent 300 hours on the moon, not even a little over a week. 12 Americans, not a whole lot of presents, 6 places we actually landed upon. We've missed a lot of the whole moon. He also said, we don't know what we don't know about the moon. He pointed out, for example, that 37 years after he walked on the moon, we found out, hey, there's water on the moon in those craters. And as you guys know, going to Mars or going in deep space, we have to have water for human beings to survive. So that's a great project. My question is for you, Dr. Zurbuchen. You mentioned we can discover things on the moon to help us go to Mars. As I mentioned, Captain Cernan agrees with you. Can you go further detail on this topic? How can we help us learn more about the moon that gets us to Mars quickly?
That's a really important question that you're asking, a question that we're thinking about both from the science side, but also from the human and technological side. There's a fundamental difference about being in low Earth orbit and being away from the Earth, and that has to do with the radiation environment that's out there. The radiation environment, of course, is much less in low Earth orbit because of the fact that we have a magnetic field that kind of pulls away, directs away particles that come in from deep space. That radiation environment, living in that environment for longer duration is something that is existential to go to Mars, but it's something we're going to learn being near the moon, on the surface of the moon for a long time. We want to learn about resources like you talk about. Ultimately, what we want to learn is actually live off the land, if you want, relative to the resources that are there, whether it's the water that are, some of resources that may actually lead to companies or kind of commerce in other ways. That is a positive thing. It's something that we should think about. That has guided us. We would not sit in the United States here as this country we love if the people ahead of us did not think that way. So it's about learning how to do that, also to developing the technologies to sustain life in deep space.
And as you mentioned, too, having access to water out of our orbit is huge because with our current propulsion systems, it takes 10 pounds of propellant to put up 1 pound of water into orbit. So that means you have to have a huge rocket pulling all that water out of Earth, going through our atmosphere. If it's there on the moon, it's there for the taking. And I think that's something we should push, and getting there in 5 years is very, very doable if we make a commitment. Another question for you, Doctor, is about the President's budget request for science. It's a decrease from the FY19 appropriation, but still the highest ever proposed by administration. It's increased again. The President added an amendment there. He put on another $90 million. What does NASA plan on doing with that extra $90 million, and how does that differ from the existing Commercial Lunar Payload Services Initiative?
I'm really glad for that question because it relates directly to what we just discussed. What we seek to do ahead of a human landing is actually bring robotic mobility, so a rover to the south areas, the polar areas of the moon, and actually look for water and the state it's in, just in a way as Dr. Sykes talked about in his testimony. That's what the additional $90 million allows us to buy that services to go over there and accelerate going there ahead of humans going to that very region.
I have a few more questions, but not much time, so I'll yield back the balance of my time.
Thank you very much. The chair recognizes Ms. Wexton for 5 minutes.
Thank you, Madam Chair, for yielding, and thank you to the witnesses for coming to testify today. I am from Virginia, where we have 2 incredible NASA facilities at Langley and Wallops Island. They both play important roles in many of NASA's scientific missions, from launching CubeSats designed and built by Virginia students to testing key components of the Europa Clipper. So we know firsthand how NASA's science missions increase our understanding of our solar system, deep space, and our own planet. Dr. Gentemann, you wrote in your prepared testimony that the PACE and Clario Pathfinder missions proposed for cancellation in the administration's FY 2020 budget request are considered part of the program of record for the decadal survey recommended to be continued as a top priority. What would the impact be to our scientific understanding of the Earth and its changing climate if these 2 missions were canceled?
Thank you, Ms. Wexton. So the PACE mission is the Plankton Aerosols Cloud Ocean Ecosystem. It's a critical mission for quantifying the role of the ocean ecosystem in the global carbon cycle. When it's launched, it will give us unprecedented insight into the Earth's ocean and atmosphere, and collecting data on these systems is critical to understanding their effects on climate and Earth's habitability. The instruments on PACE will allow for a more detailed understanding of carbon uptake by the various phytoplankton species. And this is sort of the crux of it. This data will allow scientists and policymakers to be in a stronger position when prioritizing climate change mitigation strategies. The Clario Pathfinder mission is designed to demonstrate in-space satellite intercalibration. And I've been involved in satellite calibration for over 20 years, and having this capability is just incredibly exciting to me as a scientist. It's essential to provide accurate, well-characterized data, and it will provide the ability to intercalibrate instruments in space at accuracies 5 to 10 times beyond current capabilities. These are both part of the assumed baseline program of record, and the decadal survey, all of these observations from these missions are interwoven into what sort of societal benefits we can expect by following this recommended guideline and including new missions so that it's all builds on each other. Thank you.
Thank you very much. So I served in the state legislature in Virginia before I came to Congress, and one of the things that we have, it's kind of unique in Virginia, is we have a one-term governor. And as a result, we've got 4 years when one thing might be a priority for that governor, and then another governor comes in 4 years later and changes the priority. So it had been cybersecurity, and now it's high-tech manufacturing or whatever it may be. So seeing this decadal survey that is peer-reviewed and scientifically based is very encouraging to me, rather than have the politics or the what a current administration may want to be focusing on be the focus. But Dr. Sykes, you testified that there were some shortcomings in the way that this program is administered and the issues with transparency and competition. Can you elaborate on that a little bit more?
Yes, I believe competition is key, particularly in our research and data analysis programs, that we need to make sure where the money's going, to what parties, and so there's some open questions about that. One of the main things which has come up over the last 6 years or so has been the hiding of costs of proposals from reviewers. I mean, this was something that for the decades that I've been in the community and serving on panels and stuff was a regular thing of being asked, well, is this good? Is this cost-effective proposal? Or, gee, this proposal is 3 times as much as 3 lower ranked proposals, but what's the value of those 3 proposals taken together? That's not something a program officer can really answer. I had an interesting, and I don't want to waste your time, experience where a proposer, top-ranked proposal, wanted all the money of the program.
Imagine that.
So we dealt with that. But so making this information available, being transparent about costs, and also in terms of compliance with the decadal, just being open about what budgets are actually being spent. As you see in my testimony, there's some pretty interesting variations in terms of in the planetary side, what was considered research and analysis programs from one month to the next.
Okay. Thank you very much. I'm going to yield back.
Thank you, Ms. Wexton. The chair now recognizes Mr. Posey for 5 minutes.
Thank you, Madam Chair. When you talk to people who aren't familiar with history, and you mentioned the importance of our space program to the survival of our species, you get some chuckles and you even get some harassment. A lot of that diminished somewhat when we had that relatively small asteroid implode over Russia, 1,000 miles from the nearest living person, and injured 1,000 to 1,500 people. It did wake up some people to the possibilities. The Planetary Science Division of the Space Mission Directorate is responsible for the Planetary Defense Coordination Office, which searches for, characterize, catalogs near-Earth objects that could collide with the Earth. NASA established the Planetary Defense Coordination Office in 2016 in response to the NASA Inspector General's report. And the Trump administration is calling for a significant increase in near-Earth orbit funding. Congress asked NASA to identify 90% of all hazardous near-Earth objects by 2020. NASA recently provided us a report that indicated they're not able to reach the goal in that time period, but that the National Science Foundation's large synoptic survey telescope, coupled with a space-based infrared mission, could accelerate the survey. And so, Mr. Zurbuchen, I just wonder if you can tell me if NASA is now ready to go and what the time outlook may be.
Thanks for the question. We're committed, of course, that to achieve that goal. We're not going to make it by 2020. I should have started a few years before, sorry. But no, I mean, look, I mean, we are, what we're focusing on are 2 things. First of all, we want to use any and all assets that are available, whether it's from the National Science Foundation or from our own missions, to look at the data that are there and include it into the very database that you're talking about. For example, the TESS mission that's out there in astrophysics is one of those sources that we're piping into that very analysis. The second one is through the increase by close to a factor of 3 of that particular budget line that I've led together with our team, we're enabled to actually do the very mission that you're talking about. In fact, we've started to invest in the technology, the sensor technology, to detect those very cold objects. And it's our expectation to go forward with that mission in the next few years as a budget which becomes available in that line.
Mr. Sykes, did you want to comment on that? You had the largest grin when we were talking about survival of the species.
Well, we do have the technology, and with the moving forward of the NEOCAM mission that provides the space-based infrared component. I mean, the limit to Earth-based observatories, and I'm a telescope jockey myself, is that you can only observe at night, and when you can only observe at night, that means that you can't see much. The interior towards the sun, or interior of the Earth's orbit towards the sun, and we can be hit by stuff from there too. So the NEOCAM mission is placed at Earth Sun L1, in between the sun and the Earth, closer to the Earth, and it's scanning tens of degrees, closer to the sun. So it captures well inside the orbit of Venus. So all the objects that are moving in there. And there's an interesting thing. I'm sorry, please cut me off. That for instance, those Chelyabinsk-sized 20-meter type objects that exploded in the atmosphere over Russia. Well, about 5 times as many of those objects are hitting us as based from detecting flashes in the atmosphere and infrasound than are predicted by the asteroid population models from ground-based observatories. Why is that? Well, there is a possible answer is that you could have a breakup of an interior asteroid interior to the orbit of the Earth, and we're getting fragments from that. But you wouldn't pick that up in a ground-based telescope, but you would with NEOCAM. So there's all kinds of having this combination of these ground-based sources in combination with NEOCAM is really going to put this to rest. Not by 2020, but probably within 5 years of its launch.
The longest silence I've ever heard in this committee is when the president's chief scientist, the NASA administrator, and the Secretary of the Air Force were asked in one of our committee hearings if a relatively small asteroid, the one that detonated over Russia, were headed for the Big Apple and we had a week's notice, which we wouldn't have, what would we do? That's the longest silence we ever heard in this committee. Thank you. Thank you, witnesses.
Thank you, Mr. Posey. The chair now recognizes Mr. Perlmutter for 5 minutes.
Thank you. And Dr. Sykes, never apologize for your enthusiasm. We appreciate it. We've had some tremendous panels lately, and I just want to thank all of you for being here. So I'm going to start with a couple softballs, and then we'll work it up from there. So Dr. Zurbuchen, I understand you visited my alma mater last week, the University of Colorado at Boulder. So I'm just curious what you were talking about, what kinds of science matters were generally discussed, and also how is NASA getting along with its university partners? And then, Dr. Spergel, I'll let you kind of follow up from an academic institution point of view.
We at NASA think of the university partners as just that. They're partners, they're part of our mission without whom we cannot be successful. I therefore personally visit universities on a regular basis all around the country, and I was in Colorado talking about a variety of both missions that are ongoing there, but also of ideas that are there that would make us better as we go forward. The University of Colorado is among universities unique in a sense that it's the only university I'm aware of where during a Saturday football game in the middle, the ad comes on and talks about NASA. So I love those games.
Thank you. Dr. Spergel, how do you see the partnership or the relationship with NASA working between the institutions and the agency?
Generally working well. Thank you. Generally working well, in that I see it working in sort of 2 different forms, both of which I think are important. For the scientific missions, we often have situations where some of the leadership of the mission sit at the universities. For example, in the IMAP project that was just selected, my colleague, Dr. McComas at Princeton, is leading IMAPs and working together with NASA centers. When I worked on the Wilkinson microwave anisotropy probe, we worked very closely with our Goddard colleagues. And I think universities bring some flexibility, some innovation, perhaps most importantly, really smart, eager young students. And they bring a lot to projects. And on the other hand, I think what NASA centers do well is continuity. There are long-term capabilities that sit at the centers, and I think we need a balance between the two. To echo something that Dr. Sykes talked about, another important role the university plays is in the research community. And it's the universities that train and develop graduate students. And one of the things that happens that we have to be very careful about when a mission overruns, there's always a temptation to cut the research budget and research analysis budget in order to make sure that those projects go. When those things are cut, that eliminates, graduate student careers.
Right.
Because a lot of that funding goes to students, and I think educating the undergrads and educating the graduate students is a really important role that the universities play in the whole scientific enterprise.
A couple of weeks ago, we had a young woman who was a computer scientist who was the one who knit together all the pictures of the black hole at the center of our galaxy. And she was, brilliant and excited and enthusiastic, and she jazzed all of us up. So it's important to have that energy, that enthusiasm, and that, new look at things. So let's talk about space weather for a second. We had a bill last cycle. It's coming back to try to, provide some more information about, whatever kinds of flares, radiation, et cetera, are coming to us from the sun. So can you talk a little bit, Dr. Zurbuchen, about, what we're doing with the heliosphere and those kinds of things?
The space environment of the Earth, just like the Earth itself, is a system that has both magnetic forces and plasma streams that interact with us as a technological society. The decadal of heliophysics that is driving our investments talks as a key element, a whole chapter dedicated to space weather. That chapter 7 basically tells us we should, from NASA, provide and support to our operational agencies. And for example, look at L1 monitors as a continuing kind of capability. That's something we're working on right now with NOAA. It also said that we should focus on research to operations work, and also in reverse, look at how the operational data help us drive more research. We've started programs in both of those areas and are working with NOAA to do that. It also talked about investments and knitting together to create more strength and capability. It's something that we're working on and focused on.
Thank you, and I yield back to the chair.
Thank you, Mr. Perlmutter. The chair now recognizes Mr. Waltz for 5 minutes.
Thank you, Madam Chairwoman. And thank you so much, witnesses, for coming today. So my questions today focus on the Commercial Lunar Payload Services, CLPS, the CLPS program, which is, of course, within NASA's Science Mission Directorate and provides commercial lunar landers for S&T payloads, and has been described by NASA as the first major step to return astronauts to the moon. So I'm a supporter of the program, and in fact submitted an appropriations request to fully fund CLPS in FY 2020. Bottom line, the 21st century space race is on. The moon will be a critical part of it. On May 31, NASA awarded contracts to 3 companies under CLPS, and one of these companies, Beyond Orbit, Inc., has elected to locate its lunar lander assembly facility in my district in Volusia County, Port Orange, Florida, which is fantastic, something we are very excited about. My district is just north of the Cape, and we're looking at least 50 employees coming to our community. So my questions, and forgive me, Dr. Zurbuchen.
Yeah, everybody calls me Dr. Z.
Dr. Z. So a condition, and I know there's been some questions on this already, but just to clarify, a condition of the CLPS procurement stipulates that the awardees have to be U.S. companies. So, again, can you assure Florida's taxpayers that NASA will not outsource its space exploration and will continue to focus on American companies as it has throughout its history?
Absolutely. We will use the very same processes that we're using for launch capabilities, in which we assure that the majority of all design manufacturing is right here for it to be falling under any contract that we could that we would support from NASA. We actually have initiated a review of that, an audit of that right now before we put money into that particular company. We'll do so with others. I, for now, actually think that it's a strength of the United States to attract companies that might have been invented elsewhere and come here and hire Americans and give them jobs and create economic activity right here on our soil.
No, I completely agree, and obviously there is an IP issue here. There's a national security issue. There's a number of issues wrapped around that. On top of ensuring taxpayers receive that return on investment. So thank you for that. You've also said, Dr. Z, that and I agree with my colleagues that the landers contracted through CLIPS will, quote, bring us closer to solving the many scientific mysteries of our moon, our solar system, and beyond, and what we learn will not only change our view of the universe, but also prepare our human missions to the moon and eventually Mars. So just, can you elaborate on those thoughts and explain how these lunar payloads and the broader science mission is preparing NASA for human missions to the moon, and again, then the follow-on to Mars?
If one looks at lunar science, what's really exciting about this is that the moon that we investigated during the Apollo program with the probes that we brought back today is a very different science discipline than then. For example, even in the last few years, kind of decade or so, kind of the prevalence of water in both on the inside of grains, but also in observed remotely from the moon. It's basically reshaped our view of our celestial companion. So we have those kind of questions that actually were mentioned in the planetary decadal that we can now do because we actually don't have to buy a whole billion-dollar spacecraft, but we have a chance of doing through this new methodology. There's other questions that relate to the absolute age of the solar system, questions that are out there that actually have sharpened our understanding of geologic activity in this planet that otherwise we did not think about before. It's those kind of questions we want to go up after, driven by principal investigators through a competitive process and taking advantage of that capability.
Well, you have a supporter here, presuming we need to spend those monies smartly and efficiently. And if, just in the interest of time, if you could submit for the record, I have Embry-Riddle Aeronautical University in my district. If you could submit for the record how the Mission Directorate partners with STEM institutions like Embry-Riddle for research and development, I'd be very appreciative. Thank you.
We'll do so, sir.
Thank you, Mr. Walls. The chair now recognizes Mr. Byer for 5 minutes.
Thank you. And Chairman Horner, I really want to thank you for holding this hearing. You know, we hear so much about the administration's plans, constantly changing plans, to send humans to the moon or to the Mars. It's actually great to hear about NASA's key science programs. Dr. Spergel, in your testimony, you stated that, quote, understanding the nature of dark energy is one of the most compelling problems in physics, and that Europe and China are leading the way on this. Without WFIRST, would we be behind other nations in studying dark energy?
Yes, we would. I mean, now we are partners with the Europeans on Euclid, but they're leading that study, and we're partners there. I mean, one of the WFIRST, is a mission that I think we want to do because of the compelling science it does.
Tell me why, in layman's terms, why is dark energy compelling?
It's 75% of the universe, and we don't know what it is. So it's most of what's out there. It's driving the expansion of the universe. It will determine the universe's fate, whether it expands forever, whether it's torn apart by a big rip, whether it turns around and collapses, will be governed by the nature of dark energy.
Will our research into dark energy also give us insight into dark matter?
Perhaps. we're in the embarrassing situation of not knowing what makes up 95% of the universe. We know there's dark energy. We know there's dark matter. One of the things, actually, I'm working right now with an undergraduate with my assignment for the train ride on the way back is to send him some detailed notes, is does dark energy interact with dark matter? Dark matter clusters gravitationally. It behaves differently from the dark energy. It clusters in our galaxy. So, in this room, we think there's lots of dark matter streaming through us. But again, we don't know what it is. There are a number of different ways that NASA missions are going after studying dark matter. The Compton Gamma Ray Observatory is looking for dark matter annihilation. We are mapping the large-scale distribution of the dark matter right now with Hubble. We will be able to do that with much more power with WFIRST. It can image more than 100 times the area in an image as Hubble does.
Let me jump on a W first question, because the
Yep.
president had zeroed it out in his last couple of budgets. We've put it back. We like to say here, this is the most important issue in the decadal survey that's been ignored by this administration. But in casual conversations, the cocktail party conversations with NASA scientists, they say the other side of that is that by turning over $510 million or some billions of dollars to the outside government contractors, we're squeezing out the other essential science that needs to be done within NASA.
Well, I think it's important that NASA maintain a balanced program, right? So we don't want to see WFIRST funded at the expense of severe cuts in the research program. This is why, and I think I would applaud the budget that's been, come out of the Appropriations Committee here in the House this year that provides support in astrophysics, both for research and analysis and for the WFIRST mission. And that goes beyond what was requested by the President's budget.
Yeah, thank you. Dr. Z, there's an article published 4 days ago in Scientific American that stated, and let me quote again, the White House is considering whether to require scientists from NOAA, NASA, or other agencies to participate in the review, and the review being the program run through the National Security Council portrayed as a correction to the National Climate Assessment, according to sources involved in the planning. And the article notes that Dr. Gavin Schmidt, a scientist at Goddard Institute for Space Studies, was identified by the White House as a possible participant. Are NASA scientists going to be required to debate the credibility of the National Climate Assessment? And how does NASA feel about its scientists being dragged into the climate skeptics at the White House?
So just like you, I've read the article in the press. I have personally not been engaged in any of the detailed discussions on that very issue. I would have to take additional information that you might want to know about this for the record. Generally speaking, I believe that the science that we're doing, whether it's in this question or any other question, has the same kind of rules, and that is it's perfectly fine to ask questions. We want to use the scientific method to answer those questions, and I have every belief that no matter what the discussion is, that our scientists, whether in universities or within the government, would know how to handle this and other questions.
And I certainly heartily agree that it's perfectly right to ask the questions, but you do have to concern when they say that being part of this could actually damage their careers, by giving them the taint that they're part of something that is anti-scientific. So.
I just want to say that it would be a shame if the science community would turn on people who are asked to serve their government in whatever form to help in a discussion and do what scientists do. And if somebody said, hey, we can no longer talk to you, it would be a shame if the science community behaved that way.
Great. Thank you very much. Madam Chair.
Thank you, Mr. Beyer, and thank you, witnesses. The ranking member and I think have a couple of additional questions, and then we will wrap this up. There were just a couple of things that we haven't quite touched on yet, and I want to say thank you to all of you. You've been very engaging and have been very helpful witnesses. So, Dr. Spergel, I wanted to ask you about life and physical sciences. Right now, we know you're the former chair of the Space Studies Board, and so you've looked across NASA's activities. And given that this science helps us understand how microgravity, how space environments impact human physiology and physical systems, and that this research is helping inform our space exploration. That right now this is under the Human Space Exploration Operations Mission Directorate, which is absolutely understandable. What I'd like to hear is your views on how effective this placement of life and physical sciences is under the human exploration mission, and in enabling our scientific progress, and if you foresee any need for any potential changes moving forward in the placement.
There's very good science going on in life and physical sciences. That said, I'm sometimes concerned that the Exploration Directorate does not have the culture of scientific review that SMD has. I think one of the real strengths of SMD is whether you're looking at big mission proposals or a small research grant, everything is evaluated by peer review, and most everything is competed, and I think that's very important. I think for physical and life sciences, doesn't matter so much whether it sits in exploration or sits in SMD. I think the argument for sitting in SMD is it's doing science. The argument for sitting in exploration is that it informs, particularly the life science aspects, the exploration mission. I think what is important is that it operate under the principles of competition and peer review.
Thank you very much. And I want to turn our attention now. Several of you have addressed the issue of graduate students filling the pipeline, and so Dr. Z, the GAO and the NASA Inspector General have both identified challenges with workforce shortages related to our science missions, and clearly that is an issue moving forward as we delve into this. So I'd like to hear what your biggest challenges, what are NASA's biggest challenges to sufficiently staff NASA science missions, and your insight in the most efficient or effective ways to address those.
The IG report that you're referring to specifically focused on Europa Clipper. And this has been with me for the year, so it was no surprise whatsoever. I'm focused on it. The issue there is that we're right now finishing off the Mars 2020 lander, and frankly, the top talent is working on that, pushing it over the finish line. I visited the group last week and actually had a review of that work yesterday. The good news is we're on track and we're making a lot of progress. The bad news is some of the people that we were going to put on the next mission were finishing off Mars 2020. That has to be the highest priority. So we will take the recommendations as provided by the AG, look at the schedule of what we're doing and going back. What I don't want to do is increase necessarily the center size. What I want to do is think about how we distribute the work and how we in fact space strategic scale missions relative to each other to make sure that we don't step on each other's feet. The other thing that I've talked to the director about is really focusing on mentorship of that next generation leader that is out there. I'm strongly believe that the most important predictor for our leadership 10, 20 years from now is the talent that we're attracting and growing right now in our organizations. So I focus on that as a second priority.
Thank you. Would any of the other witnesses like to comment on that last question?
I believe what Dr. Zurbuchen was referring to is operational personnel, and but when it comes to science, that's science team. That's another issue because the Mars scientists are not the people that are working on the Europa mission, and and there seems to be some kind of consistent over the years scaling down of science team population and support, and relying more on some of the research programs to try to pick up the slack for analyzing the data. And of course, research programs can't do that in real time, which is what missions need. So so that's another issue. And as far as the young people are concerned, I think it doesn't help young people to be pushing the profession if there's no early career, if there's no mid-career. And so we need to be looking at that as well.
Thank you, Dr. Sykes. Dr. Spergel, did you have?
Yeah, I just want to comment that one piece of this problem is the changing enforcement of our immigration laws, that we attract outstanding scientists from throughout the world to study here. And many of the best want to stay here. And I think it's important that we remain open to these outstanding scientists who want to remain here.
Thank you. Dr. Gentemann.
I'd also like to emphasize, I think we're at the attracting new talent, we're right at the cusp of this very exciting time in science where how science is being done is being reorganized. Within cloud computing and within open source software, suddenly the types of questions that you can ask are completely different because you've sort of put aside a lot of the data wrangling and you can handle the information that you have very differently. And being able to attract very exciting, cutting-edge young scientists means that we also have to evolve as scientists and how we do science so that we can attract them and let them know that, you know, interdisciplinary science and open source software will help them build their careers. And I think it's a very exciting time for science, and I think that we have a good chance of attracting these young, technologically capable people. Thank you.
Thank you very much. Mr. Babin.
Thank you, Madam Chair. I just have a couple of questions. Dr. Zurbuchen, NASA is increasingly leveraging novel ways to acquire science data, such as database, hosted payloads, ride shares, and CubeSats. Can you speak to the progress that NASA has made on this front?
I really appreciate that question. We look at commercial opportunities like that as opportunities to get more science per dollar. That's the motivator for us. Instead of building a whole spacecraft, we can take data that a commercial entity might acquire for other market needs and make that data available to the public. We have, at this moment in time, besides the commercial lunar initiative we already talked about, a handful of other programs in play in which we're experimenting and learning about that. The most important of which, in my opinion, is the one focused on the data of our planet. We're in the middle of a year-long trial period. Frankly, what we're trying to learn is how to price into market what we should pay for data. And that's a really important thing because on the one hand, we want to spend, of course, support our own U.S. companies. On the other hand, we also are deeply aware that we're spending taxpayers' money. So we're trying to figure out how to find that right price point. That's exactly what we're learning right now. There's other experiments just like it.
Okay, well said. Also, the budget request proposes launching the Europa Clipper on a commercial launch vehicle despite appropriations laws that require the mission to be launched on an SLS to decrease the transit time and maximize the science conducted around Europa. How will the mission science be impacted by this particular decision?
If we launch on a commercial launch vehicle that could currently be available, it would add between 3 to 5 years or so of transit time, depending on how we go there. That would have, of course, cost relative to the overall science team, because we don't want to fire every scientist and then somehow hope we can hire them back. Right. We need to keep essential teams there. It would, of course, require some resilience, and depending on where we fly by. For example, there's orbits where we would fly by Venus. Venus is a hot planet, so we have to do a different thermal design as we fly by there. So it's important to us to figure out which way we're going to go as we go forward. Of course, we will follow the law.
You bet. You know what? I've got one more I want to ask, if you don't mind. Dr. Sykes, sometimes missions are delivered under cost. In order to incentivize cost-effective development of principal investigator-led missions, should NASA, and this is to you as well, Dr. Zurbuchen, should NASA explore the possibility of allowing the principal investigator to use funding saved on development for research and analysis activities? If both of you guys would, you gentlemen, like to answer that.
I think that in the context of the cost cap missions, that we don't want people to be busting the budget by borrowing from Peter to pay Paul here.
Exactly.
And I think that, and we don't do accounting across many years on these missions. So I don't know if that would be workable.
Okay.
So generally speaking, even though we have not made it a policy, what we have done to incentivize people under running their budget is by enhancing in some way, sometimes one-to-one, their research program. So many of the researchers, frankly, what motivates them for a given mission, a PI class mission, is that they want to do science, that the mission is a path to the goal. The goal is the science. And so what we're trying to do is encourage them by basically not ripping away the money that they save, the government and all of us, but reinvesting that into a team. Because obviously we don't have just a good scientist. We already checked that. We also have a good leader. So we want to invest in those people.
Thank you. Thank you very much. And with that, I yield back.
Thank you very much, Mr. Babin. Before we bring this hearing to a close, I want to sincerely thank all four of you for being incredibly good witnesses. Your insights, the clarity, the way you answered questions, and the reminder of the importance of the work that NASA Science Mission Directorate does, and the importance of balancing the needs of science and being responsible stewards of our taxpayer dollars, as well as, I think, Dr. Spergel, the reminder of the known unknowns and the unknown unknowns that are out there. So thank you all for being with our committee today. The record will remain open for 2 weeks for additional statements from members and for any additional questions the committee may ask of the witnesses. The witnesses are excused and the hearing is now adjourned.